evening and welcome to the South Downs Planetarium in Chichester for another of our virtual planetarium shows. Well, what an exciting few days it's been with the successful touchdown on the 18th of February of the Mars 2020 Perseverance rover on the surface of the Red Planet. After a 293 million mile trip from Earth taking nearly 7 months, it was the last 7 minutes of that journey that proved to be the most nail-biting of finales. Landing a spacecraft on Mars is never easy, and this was the largest, heaviest, cleanest and most sophisticated six-wheeled rover ever sent to Mars. So let's hear from some of the scientists and engineers anticipating that landing, an event that so many of them had been working tirelessly towards for many years.
Nothing can be taken for granted when you get to Mars. There's a lot of things we just don't know.
Space always has a way of throwing us curveballs and surprising us.
I mean, until we get the data that says we're on the ground safely, I'm going to be worried that we're not going to make it.
Entry, descent, and landing is often referred to as the 7 minutes of terror, because it takes about 7 minutes to get from the top of the atmosphere of Mars to the ground safely.
The spacecraft has to do all of this by itself.
There are many things that have to go right to get Perseverance onto the ground safely.
There's a lot counting on this. This is the first leg of our sample return relay race. There's a lot of work on the line.
Starting about 10 minutes before atmospheric entry, we get rid of really the spacecraft part of the rover that's been supporting us.
We come screaming in to the Martian atmosphere at 12 to 13,000 miles per hour.
And the heat shield is what dissipates all that initial energy through friction.
The vehicle will continue actually flying itself through the atmosphere. It's sort of like a transforming vehicle that went from a spacecraft and now it's kind of like an aircraft actively guiding itself.
When we're going slow enough, we deploy a parachute.
The biggest supersonic parachute we've ever sent to another planet. It's critical for slowing down the vehicle.
Perseverance's entry, descent, and landing borrows heavily from that of Curiosity.
But fundamentally, Perseverance is a different rover. She's bigger, she has different instruments.
We've added a lot of smarts on the inside to make it more capable so that it can deal with the landing site that we've given it.
The science team identified Jezero Crater as basically an ancient lake bed and one of the most promising places to look for evidence of ancient microbial life and to collect samples for future return to Earth. The problem is it's a much more hazardous place to land.
You look at Jezero, all you see is danger. How do we go to a site that we never thought was safe enough to go to before? So the heat shield, which has protected us all the way through entry, is no longer necessary. We need to get that off so that we can actually see the ground. And we can see the ground in a couple different ways.
Perseverance will be the first mission to use terrain relative navigation. So while it's descending on the parachute, it will actually be taking images of the surface of Mars and determining where to go based on what it sees. This is finally like landing with your eyes open. Having this new technology really allows Perseverance to land in much more challenging terrain than Curiosity or any previous Mars mission could. Amongst the rocks and the craters and the cliffs, these things are hazardous to the rover, but these are the things that are interesting to the scientists.
Once Perseverance has figured out where she is, we jettison the back shell and parachute and light up our rockets. Those rockets help us steer to a safe landing spot that's nearby.
That descent stage takes us all the way down to about 20 meters off the ground.
That's when we start the sky crane maneuver. And once the rover has hit the ground, the descent stage will cut loose from the rover and fly away to a safe distance. Surviving that 7 minutes is really just the beginning for Perseverance. Its job, right, being the first leg of sample return, to go look for those signs of past life on Mars. All that can't start until we get Perseverance safely to the ground. And then that's when the real mission begins.
So let's see what actually happened when the crucial time arrived.
We are starting the straighten up and fly right maneuver in preparation for parachute deploy. The navigation has confirmed that the parachute has deployed and we are seeing significant deceleration. SkyCrane maneuver has started. About 20 meters off the surface.
We're getting signals from MRO.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life.
Looks like we're getting the first image.
This is the most amazing thing. This is what NASA does. This is what we can do as a country.
And while Perseverance was descending towards the Martian surface, its parachute trailing behind, the high-resolution imaging experiment HiRISE camera aboard another spacecraft, Mars Reconnaissance Orbiter, which was in orbit above Mars, managed to capture the descent, even though it was 430 miles from Perseverance at that time and travelling at 6,750 miles an hour. A truly amazing shot. You can see it there in the enlarged inset top right. The extreme distance and high speeds of the two spacecraft were challenging conditions that required precise timing and for Mars Reconnaissance Orbiter to both pitch forward and roll hard to the left so that Perseverance was viewable by HiRISE at just the right moment. During the final 20 metres or so of its descent, Perseverance is lowered to the surface, suspended under a rocket-powered sky crane on 3 bridle cords. Here is an actual picture shot from the underside of that sky crane, showing Perseverance dangling below, moments before it touched down on the surface. Such a view wasn't possible on previous missions. And this is where it landed. The first high-resolution colour panorama of the site to be sent back by the hazard avoidance cameras on the underside of the rover. It is actually a very flat location. The curvature of the horizon is caused by lens distortion. We can see the shadow of the lander set against the dusty reddish-brown landscape strewn with small boulders. It was a perfect spot to set down. Here is the location of the landing site marked on a high-resolution image of part of Jezero crater. The ancient river delta, which is the principal target of Perseverance's mission, is in the upper left quadrant of this image. The landing ellipse, marked in white, is about 5 miles from left to right. You can see that Perseverance has come down only about 1.5 miles from the edge of the delta. The rover used maps stored in its memory to avoid landing hazards within the landing ellipse during its propulsive descent phase. This enabled Perseverance to target a safe landing location within Jezero crater. Another of the first images from the surface showed one of the rover's 6 wheels. But already there is a puzzle. Look closely at the small rocks to the left-hand edge of the frame. The rocks have interesting holes in them. This already has the scientists curious to see what would cause them. Are these rocks volcanic or sedimentary? What story could they tell? So what happens next? Well, Perseverance is healthy and is undergoing testing of all of its systems. After spending a few days being checked over, it will take a short drive in its new home, possibly before the end of February. And what is it going to see? Here is another high-resolution view of the landing site from orbit, courtesy of the HiRISE camera on Mars Reconnaissance Orbiter. The level of detail shown is extraordinary. Between the landing site of the rover, marked by the white arrow, and the edge of the ancient river delta, there is an extensive dune field and a small crater with a dune field on the crater floor, and beyond that an area of smoother terrain. It is great territory for roving. As for the Mars helicopter, Ingenuity, it could take its first tentative test flight as early as this April. So this area and its surroundings is going to be home to Perseverance for many years to come. Its broad mission is to explore for several years, gather data and collect samples which will be retrieved and returned to Earth for analysis by a future mission, a joint venture between NASA and the European Space Agency. Who knows what Perseverance will discover? Well, also in today's presentation, we shall be taking an in-depth look at Earth's nearest neighbour, our Moon. But first, we're going to take a very quick tour of the wintertime stars, so I'll just make my way over to the control console of the star projector and we can get started. We begin our journey looking north. It's 7 o'clock in the evening, and this is the view you might see on a clear, cloudless winter's night from the middle of a small town or perhaps an urban fringe area. From such places, there's always a certain amount of light pollution. This reduces the number of stars you can see, but it's still possible to make out the brighter stars and the most important of the star patterns, even from urban areas. If, however, you live in the countryside or a more rural area, you may be lucky enough to have really clear, dark skies. So let's see the difference it makes between the sky that you can see from a small town to the sky you can see from the countryside. It's now possible, seeing those fainter stars, to be able to make out all of the principal star patterns, or constellations as we call them. Looking north at this time of year, the star pattern which we're going to begin with is one that nearly everybody knows. We call it the Plough, the North Americans call it the Big Dipper. It's basically shaped like a saucepan, and at this time of year, in the early evening, the Plough is coming up in the northeastern sky. I'm circling the pattern of the Plough here. You can see there are 7 main stars in that saucepan shape. Here's the bowl, and there's the handle. Now, these stars are actually part of a constellation called the Great Bear. The Great Bear actually contains a lot more stars than just those 7 main ones. The head of the bear is over here. Her front paws, her back paws, and back legs. So the Great Bear actually covers quite a large area of the sky, with the bowl of the Plough being the rear of the Great Bear's body and the handle of the Plough being the bear's tail. Now you can find the pattern of the Little Bear, or Little Dipper as it's sometimes called, by using the stars of the Plough as a signpost. The 2 stars at the top of the bowl, Merak and Dubhe, are often called the pointers because if you take a line from those 2, we come to this star here. It's a very famous star, the North Pole star Polaris, and it marks the end of the Little Bear's tail. You can see the faint line of stars here and the box shape at the bottom. That's the Little Bear. Now I have an outline for the Little Bear, so let's see what that's like. Polaris, the North Pole star, is not a particularly bright star. However, it is a very important star because it's the nearest naked eye star to the North Pole of the sky, marked here by the tip of that white arrow. The constellation of Draco the Dragon is a long and winding line of stars. The head of the dragon, here, is a quadrilateral of stars. And then we have the dragon's neck and shoulders, its back, and its long tail. The dragon's tail is this line of faint stars in between the Plough and the Little Bear. You can imagine it breathing fire from its mouth just like this. Now if we go from the pointers in the Plough and on through the pole star to the other side, we come to another very well-known pattern of stars. It's shaped like a letter M that's been sat on. It is Cassiopeia, a very distinctive pattern, high up in the northwest at this time of the year, on the opposite side of the pole to the Plough. Cassiopeia is one member of our celestial royal family. We have Queen Cassiopeia, and then we have her husband, King Cepheus, Cepheus is a rather difficult pattern to make out. It comprises a faint box of stars with a triangle on the top. Cepheus may be found below and to the right of Cassiopeia as we look at it here. Then we have their beautiful daughter, the Princess Andromeda. Here you can see the outline of the beautiful Andromeda. You will notice just here, to the right of Andromeda's waist, that little elongated smudge of light in the sky. That is the Andromeda Galaxy, the furthest thing you can see with the unaided human eye on a really clear, dark night. We live in a galaxy, the Milky Way, and its stars are all around us. Andromeda is the nearest large galaxy to our own Milky Way. Over time, the northern stars and constellation patterns appear to be revolving slowly around the north pole of the sky. Polaris, so close to the pole, hardly moves at all, but the Plough will rise higher up in the northeast, while Cassiopeia will sink lower down in the northwest. Well, we're now going to turn our attention to the southern part of the sky. Now we've turned to face towards the south at 7 o'clock in the evening. Once again, we're going to start by looking at the view from the middle of a small town or perhaps an urban fringe area. But even from such a place, the southern sky at this time of year is magnificent. And because we have some easy to find star patterns, it's not too difficult to find our way around. First and foremost, we have Orion the Hunter and Sirius the Dog Star, the brightest star in the night sky, and then all of the well-known star patterns around Orion. Many of their stars are quite bright, so they can be seen even in a light-polluted sky. Of course, we also have the red planet Mars visible at the moment, moving slowly eastwards on the border of Aries and Taurus. Over a period of a week or so, you'll notice its motion. Mars is the only bright planet that we can see in the evening at present. We also have a lovely 13-day-old moon rising in the east among the faint stars of Cancer the Crab, below the more obvious stars in Gemini the Twins. Over the past fortnight, we have seen the moon slowly become more obvious in the evening sky. Let's see how the moon has changed during that time. This is what the moon looked like 12 days ago, just after new moon. And here as a waxing crescent 8 days ago. Here we have first quarter or half moon 5 days ago. A waxing gibbous or three-quarter moon only 2 nights ago. And this is what the moon looks like tonight. In just 2 days, it'll be full moon like this. In native North American folklore, this full moon would be called the snow moon, because this would be the time of year when the snow would traditionally be deepest in North America. In the United Kingdom and Northern Europe, we tend only to name the September full moon, which is the harvest moon, and the October full moon, which is the hunter's moon. But the native North Americans had names for all the full moons in the year. These changes in the moon's appearance are called the phases of the moon. In this animation, we see the moon orbiting the Earth every 27 1/3 days. Earth and moon are not to scale here. The sun is illuminating both the Earth and the moon, but the sun can only light up half the Earth and half the moon at any one time. Half of the Earth is in daylight and half in darkness. Half of the moon is in daylight and half in darkness. Day and night on the moon each last for about 2 weeks. But as the moon orbits the Earth, we see varying amounts of the half of the moon that is lit. And this is what causes the phases of the moon. You can see the cycle of the moon's phases speeded up in this video. But you may also notice something else here. The apparent size of the moon is varying slightly. Sometimes it looks a little bit larger and sometimes a little bit smaller. This is because the orbit of the moon around the Earth is not a perfect circle. Sometimes the moon is a little bit closer and sometimes a little bit further away. The varying distance of the moon from the Earth, from the centre of the Earth to the centre of the Moon varies between 222,000 miles when the Moon is closest and 253,000 miles when it is furthest away. When the Moon is closest to the Earth, we say it's at perigee, and when it's furthest away, we say it's at apogee. Something else you may notice in this animation is that the Moon appears to roll back and forth, a bit like it's wobbling. This wobble is called libration. The word comes from the Latin for balance scale and refers to the way such a scale tips up and down on alternating sides. Now the phases of the Moon repeat in a continuous cycle, but in a slightly longer time than the orbital period of the Moon. Because the Moon is not only going round the Earth, but the Earth and Moon together are going round the Sun, the phases of the Moon repeat in a slightly longer cycle of 29.5 days. So the interval between one full moon and the next is 29.5 days, and the orbital period of the Moon around the Earth is 27 1/3 days. Now the difference between these two time periods means that the different phases of the Moon will occur at different distances of the Moon from the Earth during the year. The two cycles are out of step. Sometimes full moon will occur when the Moon is near perigee, sometimes full moon will occur when the Moon is near apogee, and there will be many full moons which occur at some distance in between the two. The February full moon is one of these. We'll return to the Moon a bit later on to look at its surface features, but first let's take a quick trip around the southern night sky. Orion has many fairly bright stars and is a great signpost to help us find our way around. Here's Orion the Hunter, with its 4 main stars and the 3 stars of Orion's belt that point down to Sirius the Dog Star, the brightest star in the Big Dog, Canis Major. Then we've got Procyon, brightest star in the Little Dog, Canis Minor, the twins of Gemini, Castor and Pollux, Capella in Auriga the Charioteer virtually overhead, then down to Aldebaran, one of the eyes of Taurus the Bull, and on to Rigel, the bottom right star of Orion as we see it, and back to Sirius again. Those bright stars make up an asterism called the Winter Hexagon, and it includes all of the most obvious stars in the area around Orion. But now we're going to imagine that we are transporting ourselves from an urban fringe location to a nice dark countryside site. What a magnificent view we have now. I just want to draw your attention again to Cassiopeia the Queen, appearing here more like a letter W and high up in the western sky. Moving to the left of Cassiopeia, you can see there's a long line of stars here and another there, which together look like the shape of an upside down letter Y. This is the constellation of Perseus, the great warrior and hero of Greek legend who was involved in many adventures. In between the small triangle of stars at the top of Perseus and the W of Cassiopeia, you may just notice a faint misty patch. With good eyesight, you'll see 2 misty patches very close together. That is a beautiful pair of open star clusters, the double cluster in Perseus, also known as the Sword Handle. It is a fine sight in a low-power rich field telescope. If we follow the line of stars in Perseus downwards, we eventually come to one of the most magnificent of all open star clusters, the Pleiades or Seven Sisters. We say the Seven Sisters because most people can make out 7 stars on a clear dark night with the naked eye. With binoculars or a small telescope you will see many more. They are all blue-white in colour. Now the 7 sisters are part of the constellation of Taurus the Bull. The head of the bull is this V-shaped cluster of stars known as the Hyades, with the red star Aldebaran marking one of the bull's eyes. The Hyades is an older and more scattered cluster than the Pleiades. Then we've got the horns of the bull, one of which goes out here and the other goes out here. If we add in the outline of Taurus the bull, you can see it is a magnificent pattern. I mentioned earlier the bright star Capella, which is virtually overhead in the early evening at this time of year. It's a yellowish star, the sixth brightest star in the night sky. Capella is part of the constellation of Auriga the Charioteer. It's a sort of five-sided box shape like this. Then we come down to Orion the Hunter. This magnificent grouping contains 4 stars in a sort of a rectangle shape, with the 3 stars of Orion's belt diagonally across the middle. Here we see the outline of Orion superimposed on the main stars. All of those main stars have names. Betelgeuse, top left, Bellatrix, top right, Rigel, lower right, and Saiph, lower left. The 3 stars of Orion's belt are in order Mintaka, Al-Nilam, and Al-Natak. The sword of Orion curves down below the belt, and near the tip of the sword, just there, you can see a faint misty patch. That is the Orion Nebula, a stellar nursery, a glowing cloud of gas and dust inside which new stars and new planets are being born right now. Orion is one of the few star patterns that really does look like the character it is supposed to be. Above the stars marking his shoulders, his head is here, and in his right arm he is holding a wooden club, and over his left arm is draped the skin of an animal that he's killed. When we were looking at the northern sky, we used the plough as a signpost to help us find other star patterns. Now we're looking at the southern sky, the stars of Orion can be used in the same way. The 3 stars in Orion's belt point down to Sirius the dog star in the constellation of Canis Major, the big dog, which is always rather low down from this country. If you take the 3 stars of Orion's belt and go the other way, you come to Aldebaran, one of the eyes of Taurus the bull and the V-shaped Hyades cluster. Extend that line onwards and you come to the 7 sisters. Then if you take the right-hand star in the belt and go up through Betelgeuse, you come to Gemini the twins, with its 2 bright stars, Castor and Pollux. Pollux is definitely the brighter of the 2. You can imagine the 2 heavenly twins lying side by side, a bit like 2 matchstick men. Head, body, feet and arms for the upper twin Castor, head, body, feet and arms for Pollux. The bright star here, which is sort of in between Gemini and Sirius, is Procyon in Canis Minor, the little dog. Betelgeuse and Rigel, at opposite corners of the main pattern of Orion, have very contrasting colours. Betelgeuse is orangey red, while Rigel is blue-white. Betelgeuse is a red supergiant star, a star so huge that if it was dropped into the middle of our solar system, its outer layers would stretch out to the orbit of the planet Jupiter. Rigel, a blue-white supergiant star, is the brightest of Orion's stars, ranked 7th brightest in the night sky. If you look at the Orion Nebula through a telescope, it appears as a faint, misty patch. Images of it will show lots of colour, mainly red, but if you look at it with the naked eye through a telescope, it will just look greyish, because our eyes don't see colour when the light level is low. On a really clear, dark night, the view of the Orion Nebula through a large telescope is a magnificent sight. You can see wisps and filaments of gas, and you really get the idea that this is a stellar nursery, a star birth region. Tonight the moon lies below the twins of Gemini. 2 nights from now it will be full moon. Now most people are aware that the moon always keeps the same face to us. Although not exactly the same face, because, as we saw earlier, it does wobble slightly as it orbits the Earth. The side we can see is called the near side, the side we can't see is called the far side. Since we always see the same face of the moon from Earth, you might think that this means that the moon doesn't rotate on its axis. Now, while it's true that the moon keeps the same face towards us, this only happens because the moon rotates at the same rate as it is orbiting the Earth, a special case of tidal locking called synchronous rotation. The animation here shows both the orbit and the rotation of the moon. The yellow circle with the arrow and radial line have been added to make the rotation more apparent. The arrow indicates the direction of rotation. The radial line points to the centre of the visible disk of the moon. If you follow one complete orbit of the moon around the Earth, you will see that the moon has rotated once on its axis in exactly the same time. Now, when you look at the full moon, or a virtually full moon, through binoculars or a small telescope, it is, of course, extremely bright. Not bright enough to damage your eyesight, but certainly uncomfortable to look at. You will notice when you look at the full moon at this time that there are brighter areas and there are darker patches, most of which are round or thereabouts. The roughly circular dark patches are called mare or seas, although there's never been any water in them. It's just a name. These dark patches were originally giant impact basins excavated by the very first massive impacts to hit the moon early in its history. They punctured through the crust of the moon and molten rock welled up from below into those giant impact basins. But it eventually solidified and darkened, producing the dark mare regions we see today. Looking at the full moon, on the left side, as we see it in binoculars, there is the largest of these mare, Oceanus Procellarum, the ocean of storms, about 1,600 miles across on its north-south axis, a probable scar from an ancient giant cosmic impact. Then, towards the top of the full moon in the centre, there is an almost circular mare region, Mare Imbrium, the Sea of Showers, and that is just over 700 miles in diameter. Then, to the right of the Mare Imbrium, we have the rather smaller Sea of Serenity, the Mare Serenitatis, and below that the Sea of Tranquility, Mare Tranquillitatis, made famous in July 1969 when Neil Armstrong and Buzz Aldrin touched down there in their landing module Eagle and became the first humans to walk on the moon. Only 12 humans have walked on the moon, all astronauts in NASA's Apollo program of the late 1960s and early 1970s. But plans are now underway for humans to return to the moon through NASA's Artemis program. In between Mare Tranquillitatis and the limb or edge of the moon, there is a small region, the Mare Crisium, the Sea of Crises. Below Mare Tranquillitatis, to the right on the moon's disk, we have Mare Fecunditatis, the Sea of Fertility, nearest the limb, and the much smaller Mare Nectaris, the Sea of Nectar, to its left. The brighter areas are the highland regions, which are pockmarked by many craters of different sizes, evidence of the continual bombardment that's been going on for billions of years. But you won't see those craters particularly well at or near full moon because the sunlight is shining directly down on the moon and there's very little in the way of shadows to bring out the detail in those craters. But there is one type of crater that you will see really well when it's at or near full moon. Those are ray craters, and towards the bottom of the full moon there is a really bright ray crater, and you can see the rays radiating out from that crater like the spokes of a bicycle wheel. That ray crater is called Tycho, and it is about 53 miles across. Over to the left-hand side of the moon, you may see a very bright spot of light. That is the brightest point on the moon, and that is the crater Aristarchus. Then, midway between Aristarchus and the centre of the moon, we have another fairly large ray crater, not as prominent as Tycho, but certainly very obvious, and that is the crater Copernicus, about 58 miles in diameter. Remember that if you observe the moon through an astronomical telescope, the view will be inverted, so south will be at the top and north at the bottom. And in some telescopes, east and west might also be reversed. However, using a simple map of the moon's main surface features, you will soon be able to find your way around. Pick out the main features with binoculars and then use a telescope if you have one to find more in the way of detail. There is always something of interest to see on the moon. This view of the southern sky is what you'll see at 7 o'clock in the evening. As the Earth spins on its axis from west to east, carrying you, the observer, around with it, the stars slowly appear to move in the opposite direction from east to west. Here in the planetarium we can speed up time. So now you can see how our view gradually changes as we move through the evening from 7 p.m. to 10 p.m. Over a period of 3 hours, the constellations move round quite a bit. So if you're learning your way around the night sky, it is important to understand how what you see slowly changes as time passes. Well, our journey through the winter night sky and our look at our nearest neighbour, the moon, has now come to an end. I hope you enjoyed the show. I do hope that you will now feel inspired to learn more about the stars, the moon, the planets, and all the amazing wonders of the universe in which we live. Good night.